Hello everyone, welcome to this video, and in this video we're going to discuss arithmetic series. Let's start. Now, arithmetic series, it is the sum of terms given arithmetic sequence. So it is denoted by S sub n, which means sum of the number of terms. So let's start this discussing it by given a certain problem, okay? This is the problem. How? What is the sum of the first 10 terms of the sequence a sub n is equal to n? So let's see. Let's have the terms. So we have first term 1, second 2, third is 3, 4, 5, 6, 7, 8, 9, and 10. So technically, this is the natural numbers, or we could say as the counting numbers. So when we get now the sum of the first 10 natural numbers, we have now the first term to the 10th term. So when we set it up, so we have this one. So S sub 10 is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 and plus 10. Now, when we add that manually, we're going to get 55. Now, there is one mathematician who is Gauss, discovered a certain pattern in how to do this one when we're adding an arithmetic um, sequence, because we're adding a sequence. Then when we got the sum of the sequence, we got the series. So that's how it works. So once again, the setup is just the same. Now let's observe this one. So we have 1 to 10, right? Now what he did when he discovered that, he added the first term and the last term. So we got 11. Look at now, 2 and 9. It's also 11. 3 and 8. It's 11. 4 and 7, that's 11. 5 and 6 is 11. So there are 5 11s that we could see as a pattern when you're adding the first and then going in internally in this in the sequence. So what we have there is that 5 times 11, and what we got is 55. That's why we formulated now, and Gauss has have this conjecture and turns out to be a formula, which is S sub n is equal to n over 2 times the sum of the first term and the nth term. So the n stands for the number of terms. Okay, so this is now the formula for the arithmetic sequence. So now let's have now a problem. So there's a case analysis. Let's see now this case. So given a sub 1 is equal to 3 and the common difference is negative 2. So what is the sum of the 12 terms? So there are two options rather. So option 1 would be solve for a sub 12, then the sum of 12. So solving now a sub 12, or the 12th term, would be using now the general term of an arithmetic sequence, which is a sub n is equal to a sub 1 plus n minus 1 times d. So giving the input, which is 3 is the first term, 12 is the term that we're working on, and the common difference. Solving that, we have this one. 3 plus 11 times negative 2. We have 3 minus 22. And a sub 12 is equal to negative 19. Now, we can solve now for s sub 12, or this the series of the 12th term. So we have now s sub n is equal to n over 2 times the sum of a sub 1 plus a sub n. Since we're getting 12, so we have now 12 over 2 times 3 plus negative 19. So getting the sum of 3 and negative 19, we got negative 16. So multiplying now 6 and negative 16, we got now s sub 12 is equal to negative 96. So that is now the first option. Now let's go on the second option on how to solve this kind of problem. So we can go directly solving S12 or S sub 12. So we have now S sub 12. So using that, S sub n is equal to n over 2 times a sub 1 plus a sub n. Then expanding now a sub n as the general term, remember the general term, we can work that out. So working on that, we can substitute now the given 12 over 2 times 3 plus 12 minus 1 times negative 2. Solving that, we got now 6 times 6 plus 11 times negative 2. Then we have now 6 times 6 minus 22. So we have there 6 times negative 16, which is the same on option 1. And then we have now S sub 12 is equal to negative 96 as the sum of the 12 terms of the given arithmetic sequence. So let's have this problem. So what is S sub 15, or the sum of the 15 terms given now a general term, which is a sub n is equal to 3n plus 1. So there are two steps that you're going to do. First thing is this one. Identify a sub 1 and a sub 15, or the first term and the 15th term. So we can easily work that out. So we need to find out a sub 1. So a sub n is equal to 3n plus 1. Substituting now 1. So we have now 3 times 1 plus 1. And we have now 3 plus 1. And that would be 4 for your first term. Now, getting now a sub 15, or the 15th term, we have now a sub n is equal to 3n plus 1. And then we have a substitute now 15. So we have now 3 times 15 plus 1. And then we have now 45 plus 1. And we got 46. Now for step 2, we can now solve now the sum of the 15 terms. So S sub 15, so we have now S sub n is equal to n over 2 times a sub 1 plus a sub n. So we want to get now the 15 terms. So we have now S sub 15, substituting now our inputs. So 15 over 2 times 4 plus 46. So we have now 15 over 2 times 50. I cancel, I divide 50 by 2, so it turns out to be 25. And then what we got there is the sum of the 15 terms is 375. I hope you learned something about arithmetic series, and thank you for watching this video, and have a great day, everyone. And please do comment if you have any question or a reaction regarding this video. Thank you very much.